Hey guys, I'm going to be talking about adding and subtracting polynomials today. Oh yeah. And I'm going to start off first continuing to do some of those critical thinking problems. Got to keep practicing that. So let's go ahead and start off and have you pause the video and complete these 4 critical thinking problems. All right. So remember, when in doubt, start with 1 times a number. Okay, and work with your multiplication first. Okay, so for number 1, if I do that, I would have 1 times 14 is 14, and 1 plus, oh Lord, found it on my first try. 1 plus 14 is 15. So 1 and 14 are the numbers. Number 2, okay, when in doubt, start with 1 in the number. So 1 times 42 is 42. 1 plus 42 is 43, so that's not it. Next number is 2. 42 divided by 2 is 21. 2 plus 21 is 23, so that's not it. Next number is 3. 42 divided by 3 is 14, so 3 times 14 is 42. And 3 plus 14, all snap, got it. Number 3. Now, start with 1 in the number. 1 times 12 is 12. 1 plus 12 is 13. That doesn't work. Next number is 2. 2 times 6 is 12. 2 plus 6 is 8. That's not it. Next number is 3. 3 times 4 is 12. 3 plus 4 is 7. So here's the issue I have is I have a positive 7, but I need a negative 7. Okay, so I need to make sure that I remember I'm allowed to do negative times a negative. Okay, so negative times a negative is still positive 12, but negative 3 plus negative 4, that's going to be negative 7. And I have my numbers. Number 4. Okay, when in doubt, start with 1 in the number. 1 times negative 16 is negative 16. 1 plus negative 16, that would be negative 15. Well, I need positive 15, so I only need one of these two numbers to be, one of those two numbers here to be a negative. So I'm just going to change which one's my negative. I'm going to go negative 1 times positive 16. So that still multiplies to be negative 16. But now, when I add, I get positive 15. So it'd be negative 1 and positive 16. All right. Today we're going to be talking about adding and subtracting polynomials, but I want to make sure that we talk about some key terminology. Okay, so make sure you are copying stuff down for your notes. And this part does need to be copied. Make sure as we go through this, pause it as you see fit to get stuff copied down. But this first one, okay, the word polynomial. Okay. Well, the word nomial, essentially, we can liken that is terms. Okay. So polynomial has many terms. Okay. Now, a binomial, bicycle has 2 wheels. Binomial has 2 terms. Okay, so an example of a binomial would be like 3x plus 7. Okay, notice this plus sign, it separates the 2 terms. 3x is one of the terms, 7 is our other term. There's 2 terms there. Okay, a trinomial, tricycle has 3 wheels. Okay, so a trinomial has 3 terms. So an example of a trinomial would be something like 7x squared plus 2x minus 3. Okay, so we have 3 terms here. One of them is a 7x squared. The next term is a 2x, and the third term is a negative 3. Now, be careful that we do see that correctly. That is a -3. And that's called a trinomial. Okay, so polynomial basically covers binomials, trinomials, and then polynomials with like 4 terms, polynomials with 5 terms, 6 terms, et cetera, et cetera, et cetera. Binomial and trinomial are specific. Now, when we start to talk about the word degree, what the degree helps us with is this part. In all of our answers we write, we want to make sure we're putting in standard form of a polynomial. Okay, now standard form of a polynomial goes from the largest degree to the smallest degree. Okay, now what is the degree? Okay, the degree of a monomial is basically the total number of exponents on the variables. Okay. Now, it's a little bit easier to understand if we just look at a single one here. So like x to the 7th, that would be degree 7. Okay. If we had a squared b to the 3rd, there are 2, 3, 5 exponents, that'd be degree 5. Okay. Now we're going to see primarily problems that just have one type of variable. So that first one would be probably one that you would see more often. Now, the degree of a polynomial is basically the biggest monomial degree. And we're going to see that here in some examples. Okay. And then again, standard form, we basically go, if you want to put in simpler terms, the largest exponents to the smallest exponents. Okay, largest exponents to the smallest exponents. So, just for this first example here, okay, I'm going to put this table up. You do not need to copy this stuff from the table. Do not need to copy this stuff from the table. Okay, but I just kind of want to show you some different pieces. So, this first expression, 6x minus 4. 6x minus 4. I have 2 terms. I have a 6x. And I have a -4, so that is considered a binomial. Okay. Now, the degree of this binomial is 1 because I have x to the 1st right here. Okay, so that would be a degree 1 polynomial. The second example here, we have x squared plus 2xy minus 7. Plus or minus signs are what separate our terms, so I have an x squared, I have a 2xy, and I have a -7. That is 3 terms. Okay, so that would be considered a trinomial, and this would be degree 2. Okay, I have degree 2 actually in 2 spots. Okay, but the largest degree is degree 2. Now, I do want to point out problems like letter C, although they are expressions we can simplify, these are not polynomials because the polynomial, when simplified, still has a variable in the denominator. Okay, and you can kind of see that in the example here. You can't have variables in the denominators for a polynomial. Okay, the last one here, 26b squared, it's just one single term. It's got degree 2 because the biggest exponent is 2. A single term, that is a monomial. Okay, and we will see monomials when we get to multiplication sometimes. All right. Now, remember, you did not have to copy that down. But what I want to do here is I want you to write down this problem. And we are just going to put this in standard form because this is something you'll do on every single problem. Okay. So they have an answer sitting here, 9x squared plus 3x to the 6th power minus 4x. Okay. And we want to make sure we put it in the correct order, standard form. Okay. Now, they say something about identify the leading coefficient, and I'll talk about that, but that's not as important for us right now as getting it in standard form. So, the biggest exponent we have is right here. 3x to the 6th. That's the biggest degree. So that one has to be written first. So 3x to the 6th power. Okay, that one's first. The second one is the 9x squared. Okay, that's the second biggest one. So that goes second, plus 9x squared. And last but not least, we have the degree 1. Okay, it's 4x. Oh, sorry, excuse me, negative 4x. Do not forget about that negative. Okay, so this would be negative 4x. And that would be our standard form. Again, as we do our problems, okay, we are going to be doing that every single time. We always put our final answer in standard form. All right, let's start looking at some actual examples. So this is our first example. Okay, this is an example of adding polynomials. Okay, adding polynomials. Go ahead and write the problem down. Now, whenever we are adding polynomials, the first thing we want to do is check in front of our parentheses. Okay? If there's any number besides a positive 1, we got to be careful. So I look in front of this parenthesis. And I look in front of this parenthesis. Okay, and I just double check. That's 1, it's done. The second one, that's positive 1, it's done. Okay, so I don't have to do any distribution. It's already done, it's 1. Now, I need to combine my like terms. And this is not a new concept for us. It's just the problem looks different. Now, I'm going to show you a way of organizing it. Okay, so the biggest exponent first. So we have our 7y squared. And with our 7y squared goes a 5y squared. We're going to add those two together. Okay. The next one is a positive 2y. That's the next biggest. So positive 2y gets added to negative 4y. That one's done. Last but not least, we have our constants. We have negative 3 and we have positive 2. And then we're just going to add those up. So for the y squared, 7y squared plus 5y squared is 12y squared. For the y's, 2y plus negative 4y is negative 2y. And negative 3 plus 2 is negative 1. Notice, we're just adding. We do not mess with exponents when we're adding. We never have, and we still don't. Okay, that's a rule that we use for multiplying, dividing, and power property. This is not any of those. Okay, so look at example B. Let's go ahead and write this one down. We have 4x squared minus 2x plus 7. And we are adding a trinomial to that, 3x minus 7x squared minus 9. So we got to find our biggest exponent. Sorry, first. And I already did this in my head, but I got to do this here. Check in front of our parentheses. 1, it's done. 1, it's done. So I'm ready to combine my like terms. So I go for my biggest exponent first, the 4x squared. 4x squared gets added to negative 7x squared. Okay. The next biggest is our x to the first. So we have negative 2x. And we are adding 3x. Then last but not least, our constants, 7. And we have negative 9. Now, I do like to cross them off as I go, okay, because there's times that if we're not paying attention, we'll forget one. Typically, when we forget one, it's going to be in that second polynomial. And let's just add these up. So we got 4x squared plus negative 7x squared. That equals negative 3x squared. Negative 2x plus 3x is 1x. You can put the 1 in front of there if you want. 7 plus negative 9 is negative 2. And that would be our answer. Okay, end up with that trinomial as our answer. Now, what I want you to do is go ahead and pause the video, and I want you to do these two problems. Okay, for letter A, +1, +1. So I'm good to go. I'm ready to add my like terms together. So let's organize them here. We have 3x squared, and that goes with -5x squared. Those two are added together. 2x gets added to 3x, and -1 gets added to 4. Okay, remember, when we're adding, we don't mess with exponents at all. We just add the coefficients. 3x squared plus -5x squared is -2x squared. 2x plus 3x is 5x. And -1 plus 4 is 3. Okay, for letter B, always check in front of the parentheses. +1, I'm done. +1, I'm done. So I'm good to go. I'm ready to add up my like terms. So biggest exponent is my x to the third. 4x to the third. And that is the only one of its kind. So I go on. 2x squared and 3x squared get added up. We have -1x and +4x that get added up. And then we have 2 plus -8. And let's go ahead and add these. So I have 4x to the third plus 5x squared plus 3x minus 6. And that'd be a polynomial with 4 terms. That is degree 3, okay, because it's x to the third. If we're going to talk about degree, it's degree 3. Okay, when they talk about the leading coefficient, that's basically the front number in standard form. So the leading coefficient's 4. All right, that's addition. Now let's go ahead and look at subtraction. So let's look at this first problem. Okay, so we have the trinomial 6y squared plus 8y to the fourth minus 5y. And we are subtracting another trinomial, 9y to the fourth minus 7y plus 2y squared. Check the parentheses first. +1, I'm done. Uh-oh. This is the first one here. We have a -1 in front here. So I can't just be done. I actually have to distribute here. So -1 times 9y to the fourth. That's -9y to the fourth. -1 times -7y. That is +7y. And -1 times 2y squared. That's going to be -2y squared. Okay, and what I like to do once I distributed, I like to cross this off, because in the past I've made mistakes where I look back at that part. Okay, and I don't want to look back at that part when I combine my like terms. Now, let's combine like terms. The biggest exponent here is the y to the fourth. So 8y to the fourth gets added to -9y to the fourth. So those are done. The y squareds, 6y squared gets added to -2y squared. And -5y gets added to 7y. Go ahead and add these up. I would get -1y to the fourth. I like to write it like that. You can put the -1 there itself. 6y squared plus -2y squared, that'd be +4y squared. And -5y plus 7y is +2y. All right, let's go ahead and look at our next one. All right, we have the trinomial 6n squared plus 11n to the third plus 2n. And we are subtracting 4n minus 3 plus 5n squared. We have another trinomial there. Okay, again, we check the front of the parentheses first. 1, it's done. We have a -1, so I have to distribute. -1 times 4n is -4n. -1 times -3 is +3. Negative 1 times 5n is negative 5n. And again, negative 5n squared. Excuse me. And again, I like to cross this off because I don't want to accidentally include that when I combine my like terms in a second. Let's look. Biggest exponent here is the end of the third. So I have 11 end of the third, and that's the only one of its kind. We have our n squareds. So we have 6n squared plus negative 5n squared. We have our n's. We have 2n plus negative 4n. This is where I talk about make sure you're crossing things off. I still have that plus 3 at the end. And sometimes that will get forgotten because it's in that second half and we kind of lose sight of it. So let's add these together. So we have 11 n to the third. Add your n squareds. 6 plus negative 5, that'd be positive 1 n squared. 2n plus negative 4n, that would be negative 2n. Then we still have plus 3. That'd be a polynomial with 4 terms of degree 3. Okay, biggest exponent is 3. All right, what I want you to do, go ahead and pause the video and complete these 2 problems. All right. Look at it here. Oops. Positive 1, it's done. This is a negative 1, so I'm going to have to distribute that negative 1. So we have negative 1 times x squared, that's negative 1x squared. Negative 1 times 5x squared, that's negative 5x to the third. Negative 1 times negative 2x to the fourth is positive 2x to the fourth. Again, I like to cross this off. Okay, so I'm looking for my biggest exponents first, so the x to the fourth. So that'd be negative 1x to the fourth plus 2x to the fourth. Okay, so those are done. My x to the thirds, we have 3x to the third, and we are adding negative 5x to the third. And then we have our 2x squared. We are adding our negative 1x squared. And then we go ahead and add these up. So negative 1x to the fourth plus 2x to the fourth, that's positive 1x to the fourth. 3x to the third plus negative 5x to the third is negative 2x to the third. And then we have 2x squared plus negative 1x squared. That would be positive 1x squared. And that would be my answer. Okay, the last one, letter B. Okay, positive 1, I'm done. Negative 1, I have to distribute. Negative 1 times 6y to the fourth is negative 6y to the fourth. Negative 1 times 5y to the third is negative 5y to the third. And negative 1 times 9 is negative 9. Then we combine our like terms. Biggest exponent is the y to the fourth. So I have 8y to the fourth plus negative 6y to the fourth. And then y to the third is actually our next biggest, and that's over here on the right. So I have negative 5y to the third. Then I have the 3y squared. Okay, and they didn't have anything that went with them. And then I have my constants. Oops, let me get this out of here. We have negative 2 plus negative 9. And I got them all, so now it's time to add up my like terms. So we have 2y to the fourth minus 5y to the third plus 3y squared, and then negative 2 plus negative 9 is negative 11. Okay. Now, we didn't have any problems that did this, but if you have something that adds to 0, you just have to, I should say it this way, it just basically disappears and it doesn't exist. Okay. So for instance here, if I just made a quick and easy one here. If you had 2x minus 5, and I'm going to make an addition problem, plus 3x plus 5, and you do this, okay, we'd have 2x plus 3x, and we'd have negative 5 plus 5. Whoa. When you do this, 2x plus 3x is 5x. Negative 5 plus 5 is 0, so it's just gone. I do not write plus 0. So my answer would just end up being 5x. So I just wanted to make sure that we saw that, okay? Because I believe it does show up on your homework at some point. All right. You're going to be completing your homework assignment now. It is on your Google Classroom. It's practice 8-1. I did cross off a set of the problems that you do not need to do. Okay, so I did do that. And then 19 and 20 are word problems. If you have them and show your work, okay, I'll reward you a little bit with a little bit of extra credit on this assignment. So just make sure that you are actually showing your work, okay, on those two problems. Show me what you're doing. Okay, so big things are 1 to 10 and 15 to 18 on that homework assignment. You'll see that I crossed off certain problems on the actual worksheet. Okay, again, you do not have to do 18 and 9 or 19 and 20, which are the word problems. All right, once you're done with the homework, make sure that you are starting to work on any missing assignments, especially quizzes. Okay, and y'all have a wonderful day.